I'm going to be giving talk on many different emerging technologies in today's latest generation. So I'll go in. So before we go into the emerging technologies, a little about myself. So I went to Rutgers University for my undergraduate degree. I have a bachelor's in computer science with a concentration track in graphics and vision. And in my areas of interest, I'm really fascinated by are serious games, entertainment games, robotics, AR, VR, AI, ML, entrepreneurship, and brain-computer interfaces. So my full-time job is I'm a machine learning engineer at Elite CAD Designs, and then outside of that, I'm a co-founder and chief technology officer at Julia. We're a startup that's focused on developing augmented reality medical robotic solution for trauma care, specifically for the military. And then I'm also an innovation fellow with Mount Sinai Hospital, evaluating translation from research practice to commercialization. Then I'm also the senior virtual reality developer at the Museum of Science Fiction. And then I'm a venture scout for Outlander VC and Level Up Ventures. And for everyone here, anyone that's interested in connecting, I'm always happy to connect with people, whether you're a student or working professional. I'm always happy to take connections from people on LinkedIn. Right?
Yes, I already sent you the description you sent me, and I will send them all the LinkedIn to
Perfect.
connect you.
So, and then I'll go a little bit of my past experiences and really got me into emerging tech and then expose everyone into the really cool stuff going on. So past experiences, I've worked with different university labs such as Drexel University, Weill Cornell Medicine, NJIT, Rutgers, Johns Hopkins, and many more. So I originally started, so my main background is game development, VR, AR, but I have a diverse set of skills in integrating other technology into this specific space. I've worked with games for patients with neurological disorders. I've also done work with gaming AI. Then I've also worked with different government organizations such as the military, NASA, and University of Maryland Arliss, which is a defense research lab. Then I've also worked with startup industries such as Emplex, Hoth Intelligence, and Imagine Reality and Insight Solutions, which were XR-focused startups. And then prior to that, I had my own startup from a National Science Foundation funding award known as XBoost, where we focus on developing robotic exoskeleton devices combined with XR for stroke rehabilitation. And then I also have some educational experience. I was also neurodiverse mentor to neurodiverse kids at Mercer County Community College and a coding instructor at this organization known as CodeViz, where I taught elementary school and high school kids on game development technologies. Right?
Yeah.
Oh. All right. So now let's go in some of the emerging technologies. So there's a lot of real world applications of emerging technologies. So I'm going to go by the list. So embedded systems. How many of us are familiar with word terms like embedded systems? I'm sure we've heard this term. Just type in the chat or raise hands.
Yeah.
Awesome, awesome. All right, that's pretty good. So we're probably know embedded systems. They're hardware devices and applications. They could be used in our robotics, IoT, and wearable medical technology. So one example of an embedded system could be like a wearable smartwatch. That could be embedded system, or IoT devices with embedded system could be like utilizing Arduino microcontrollers with like data sensors that like capture certain data, like for example, heart rate or oxygen sensors. And some examples, like as previously mentioned, is a heart rate sensor that could do monitoring. Like if, for example, if you have a pulse physiological data sensor and you attach it to your fingertip, that can capture your heart rate in real time, beats per minute. Industrial automation systems. So like for example, factories, they use a lot of robotics technology for like packaging things. Some of that could use embedded system concepts. Other areas are like environmental sensors, like drones, for example. Drones use embedded system combined with IoTs and like Raspberry Pis for like capturing data, doing things like reporting like information back, what it sees from a camera back to like a Raspberry Pi computer, or like using network to operate and like do help with tasks such as deforestation or agricultural use cases. There's a lot of really cool application with embedded system and drones. I'm a big fan of that space. And then augmented reality, I'm sure right now we're all familiar with the whole, how many of us are familiar with this term XR, extended reality? Type in the chat or just raise your hands. Awesome. XR, extended reality. It's basically
a combination between AR and VR?
Exactly. AR, VR, MR.
Okay.
I have experience with Unreal Engine. I've made some things with Unreal Engine in VR MR.
Wow.
Yeah.
Yeah, so Unreal is very hot
I've
right
used
now in the market.
Unity before Unreal. I've used Unity, but nowadays Unreal is my tool for this.
That's awesome. No, so Unreal Engine, Unity, that's where the hot trends are. I mean, so for those of you who want to especially get into the XR stuff, I would say learn Unity first. But if you master Unreal, places will hire you. Like I'm also learning Unreal right now in my free time. Michael, great job for knowing Unreal. That's really where the hot demand is right now. It's the future, I think, of graphics technology. It's the big future. So augmented reality. So first of all, augmented reality is basically like 3D generated computer environment where you project like virtual displays into the real world. So kind of like Iron Man. I'm sure we're all Iron Man fans, like interacting with holographic technology. That's pretty much what augmented reality is. And areas you can see AR being used. Oh, there are just so many, but I want to save time for everything else. You can see it being used in healthcare, such as real-time overlays for like surgical interventions, like for heart conditions, like if you're doing heart surgery, you can have a human anatomy overlay and have visual guidance during surgical precision to know where exactly you're going to reduce minimization errors and increase efficiencies. Or there's another company known as MediVis that's AR focused specifically on tumor removals, utilizing skull surgical overlays for like the head and then mapping everything in real time, utilizing computer vision and AR with the HoloLens 2 technology. So you can do a lot of medical visualization during surgery. You can also do remote learning tools, such as in the educational space. And then another area that AR is really big in right now is for planning use, especially in the civil engineering industry for construction design, for like seeing how a building would look if you were to scale at a certain size, how things would fit, stuff like that. And then virtual reality. So virtual reality is also a 3D generated computer environment, but instead you're inside that virtual world itself. So you put on a headset and everything looks real, like you're actually there. That's pretty much virtual reality, and that's more immersive interaction, and that's also used for training. Like for example, if you're going to be the next surgeon in the hospital, you're a future surgeon, VR could be used for surgical training in how to practice surgery. So when you're doing a real-time surgery in real life, you're better prepared. It can also be used for in hazardous environmental simulation, such as space simulation. So NASA is big in virtual reality right now. They use virtual reality all the time for space operations, such as extravehicular activities or mission to Mars. That's a really, really big thing going on right now. How many of us are big space fans? Just raise of hands. All right, that's amazing. Yeah, the space industry, it's booming right now, and VR is definitely one of those applications along with embedded systems. And then there's also education. Like for example, this one company I used to work for, Imagining Reality Insight Solution, they were developing virtual reality video games for special needs students with dyslexia, specifically the phonics program, how to use games through an immersive headset to recognize letters coming at you, how to identify the difference between letter A, letter B, letter C, and really gamify that experience so it's fun when you're learning. So it's VR, I think, is going to really impact so many areas. And then now the Internet of Things. So Internet of Things is basically it's kind of picking off from embedded system, but it's kind of its own thing because it's enabling smart environment through interconnected devices. So for example, smart cities, they're smart houses built with certain Wi-Fi that can do connectivity. Like for example, um, let's say like you have a smart refrigerator and you're trying to like order grocery on it. So now there's refrigerators that use Internet of Things with Wi-Fi built into it that you can order, like a refrigerator that basically comes built with a computer. You can say that you can order your groceries. It would then send a delivery. It would send like a notice at store, and then it would then get delivered to your house. Another area is, of course, healthcare industry. So, like, for example, tracking, responding to patients' vitals in real time. So, as previously mentioned, the physiological data center, if you're using a heart rate or an oxygen sensor, that's also using IoT because that's relying on networktivity connection. Bluetooth sensors is another area of IoT. Robotics use IoT. Precisional agriculture, so drones, because drones also need to have stable connection for you to be able to see what type of task is helping it, whether it's drug delivery, deforestation, farming. So that also relies on IoT connection. And then there's machine learning and artificial intelligence. So machine learning and AI, that's both hardware and software. So it can go both ways. So you're in one area in embedded system, it's really useful, especially in robotics, is predictive analytics and decision making. So examples of that could be autonomous drones. So drones, obviously, they're having their own precision. They're using machine learning and neural networks for predictive decision, analytical decisions, knowing where to go, knowing path trajectories, knowing how to identify objects in real time. So that's using combination of convolutional neural networks, computer vision, AI, ML. Self-driving cars, I'm sure we know that's a booming topic right now. Self-driving cars is obviously using AI, ML, and then diagnostic tools for medical imaging. Like, for example, cancer detection, when you get like CT scans, MRI scans, you can use AI, ML to help detect where tumors are located within the images. All right, so now I'm going to go a little bit more into the AI ML stuff. That was a little brief I talked about. So now let me go more in depth into it and show everyone examples of projects. So artificial intelligence machine learning, as mentioned, that's really big right now in healthcare and medical imaging for early disease detection, like cancer tumors. Or, for example, when I used to work with Cornell University Medical School, they were trying to use AI ML for predictive decision making and where a catheter is being stored in a CT scan or fluoroscopic image. Autonomous vehicles like self-driving cars, that's obviously big because self-driving cars right now, they rely heavily on AI ML. Like the AI ML is like the brain behind the self-driving car, specifically the software. You have a computer it's within the cars, they're built depth sensing cameras that these cameras can then try to identify what's around their environment. And then using AI ML neural networks, you can help that can be utilized to program and help a self-driving car be better in recognizing its trajectory and environment without explicitly reprogramming it over and over again. So that's basically what a machine learning is. The goal of machine learning is to train a machine through data sets how to learn, but without reprogramming things over and over again, how to kind of learn on its own. Machine learns on its own. That's pretty much a way to look at machine learning. Because the machine should be able to also think for itself, and that's what we want. And the benefit of that is, especially with machine learning, it saves you time and having to reprogram things. And eventually, the machine gets smarter and smarter as you feed it more data sets and it learns from its mistakes. And then natural language processing, so like voice assistant and chatbots. I'm sure we know ChatGPT. That's a big booming thing right now. How many of us use ChatGPT every day in our life? Just raise a hand. Who doesn't use it?
Every hour.
That's awesome. Everyone, I think we all use ChatGPT. It's an amazing tool. It really is amazing. I love using it for my job. I love using it to ask questions. I love using it for help any drafting and emails. I think it's a big future, and especially I think we're headed in that Iron Man world where we're creating the real life Jarvis. How many of us can see that future? Just raise a hand, just for fun. All right, all right. I love this. I love this. All right, and then video games. I'm sure some of us are big gamers here. Michael, I know you're a bit, you mentioned Unreal, so I'm sure you're a big gamer yourself. I'm sure you're well familiar with AI bots and intelligent agents, that field.
Yeah.
That's big in video games.
And PC.
Oh, perfect. PC gamer. Do you use Steam?
Yeah, of course.
Awesome, awesome. I love Steam. So, like the goal of AI and especially right now, Unity right now, they have this framework known as Unity ML agents, which is basically machine learning for games. And then, of course, the overall goal of AI in a game is for the AI to get smarter, and especially it's a bot. It's a bot in a game. It could be a friendly bot, enemy bot, but if the goal of the AI is really in a game to kind of think for itself and kind of like be smarter than the person controlling the character. So, for example, let's say I'm playing Call of Duty. There's enemy AIs in Call of Duty. The goal of those enemy AIs in Call of Duty is to kind of like be more tougher, think for themselves have their own surrounding inside that environmental virtual world. And the goal is basically them trying to beat you at the game. That's basically what a game AI is. And of course, there's friendly AIs. The goal of friendly AI is to be smart enough to help the player out. So that's one area of AI. Another area of AI, then there's surveillance. So for example, border threats in airports. So how many of us are familiar with this company known as Anduril Industries? By Palmer Luckey, Anduril. It's a weapons company that Palmer Luckey founded. Palmer Luckey, he's one of the co-founders of Oculus. He founded Anduril Industry, which is a drone surveillance company that's utilizing AI machine learning for border detection, specifically for illegal immigrants that are about to cross the Mexican border to come to America. So now there's drones surrounding the border, and then using AI ML through computer vision cameras, it can be able to detect who's the enemy, who's the intruder, and then be able to alert the military in taking action to prevent border surveillance. Other areas you see probably being used is airports right now, AI, ML, computer vision, specifically through cameras, because right now as you go through like security check-in to make sure before you board a plane, nobody's carrying weapons with them. Nowadays, they have special cameras built in with AI ML algorithms that can do see-throughs and detect if there's any weapons in a bag to be able to prevent any type of certain negative incidents. And those people who are very interested in learning AI, ML, computer vision, there's a lot of great tools to learn from. So, of course, Python would be the main programming language that's used. And then some of the frameworks that you could utilize are TensorFlow, PyTorch, Scikit-learn, OpenCV. And then the platforms that generally be used, depending on what you're trying to do. One is Jupyter Labs, if you're trying to do analysis with AI ML for like predictive analysis, or PyCharm, if you're trying to do like real-time technology like surveillance use or developing simulations. PyCharm is a good IDE. So actually, I'll show a demo where I utilize AI ML and computer vision for using MediaPipe framework for hand estimation and face mesh.
By the way, in games, we have also some AI tools to enhance the visibility of the video games, to make them like a 4K look like crisp and everything. You have DSLL, if you know this technology of NVIDIA.
Oh,
that,
yes, yes,
they
yes. Is it
developed.
the ray tracing?
Yeah, for ray tracing and everything. So this technology makes like if you have a low computer graphic and you want to see the image in a 4K screen, you can do it because DSLR uses AI to enhance the image.
Oh, wow. Okay, that's something I didn't know about Unreal, but I know it's Unreal's always updated and full of surprises, so I
This
wouldn't
is
be surprised.
actually more NVIDIA thing. NVIDIA developed this DSLR technology, and
Oh,
Unreal use
yes.
it. Unreal use it
Yes.
in the games. Yeah.
NVIDIA, I know they're, when it comes to graphics and games, they are ahead of the game.
Yeah.
I look at them as the future sci-fi company, to be honest, when it comes to this stuff. All right, so extended reality. So as mentioned, VR, AR, and MR. So applications that this is used in is like immersive gaming. So for example, if you want to, let's say you want to play Call of Duty in VR, that's one way you could use XR technology for immersive gaming in Call of Duty. Or let's say you want to play Iron Man in VR. Who doesn't want to experience being Iron Man in VR? That'd be pretty fun. All right, Michael. All right. All right, and then other areas, as previously mentioned, AR medical visualization, so in real-time surgical intervention, and then VR medical training for surgical simulations, and then obviously education and industrial design. Those are obviously touched upon, but two areas I didn't touch upon yet. One area is robotic simulations with XR. That is a very hot area right now. People are developing drone simulations using XR for certain things like search and rescue. Another and that's very useful because before you even program a drone into doing real life task and operation, it's always good to test in a simulation, have a gamification where you can see in XR like if things are actually working or not. So in a way, simulations are another way to test before you do things in real life. And then another area is virtual rehabilitation. So biomechanics and games for physical therapy. So for example, people are now developing video games in the medical realm for physical rehab. Like for example, for patients with neurological disorders like cerebral palsy, multiple sclerosis, seizures, Parkinson's, and strokes. So the goal of virtual rehabilitation is really to make therapy more fun with gamification. And that's where XR can really have that big impact, especially with the immersive interaction, getting your brain, your mind excited, especially when you're in a virtual world, and then integrating other technologies like exoskeletons, combined with brain-computer interfaces like EEGs. There's a big, massive market there, especially exoskeleton. That's like a support controller, and actually I'll show demos later. A robotic exoskeleton arm device that could be like a support assisted wearable device, also using embedded system and IoT integrated chips for like doing certain tasks that will be more difficult to do, that this wearable device can provide that extra muscular support. So it's combining with that with creating exercise type games. And I'm sure we all know tools and platforms for XR. We would be using generally a game engine like Unity or Unreal. And then some of the XR headsets that are really hot right now are Microsoft HoloLens, Oculus Quest, HTC Vive, Apple
It's
Vision
actually
Pro.
not Oculus nowadays. It's MetaQuest.
MetaQuest, yes,
Yeah.
yes. And I'm just used to Oculus. I'm used to that, but yeah,
There's also a Magic Leap.
yes, Magic Leap. I know
Yeah.
about that one. Yes. I actually should mention on here too, but yeah, there's Magic Leap. And just raise a hand just for fun. How many of us own these headsets? Michael, you're on it, man. You're on it. And for those people that have never touched these headsets, okay, so anyone that's touched these headsets, raise a hand. Anyone like wear one? All right, so if you can get your access to any of these headsets right now, Magic Leap 2 and Apple Vision Pro, they're hot right now in the market. Microsoft HoloLens, they're still selling it, but they've discontinued the development of it, unfortunately. They're not further developing it, but you can still get your access to one. Like Microsoft HoloLens is also pretty cool. But I would say right now the best AR headsets are Vision Pro and Magic Leap. The best VR headsets right now, I would say, are Meta Quest 3, I would say, and HTC Vive. And then there's also OpenBCI Galia, if we're familiar with that.
Yeah.
Awesome. All right. So now I'll show little demos of like some of my projects I've done in VR AR. So I'll start with the first one. It's a HoloLens drone controller. Kind of straightforward. This is me wanting to experiment with HoloLens 2 with MRTK a couple of years ago. So I'm a big drone person. I love to 3D model drones in my free time in Blender. So I 3D modeled this drone myself using Blender software, and then I decided to like program in HoloLens just to see how it feels like controlling an AR virtual drone. And everybody can hear the sound, can see the video all okay?
Yeah, everything is okay.
Perfect. All right, so this is like me controlling it and then programming. This is some of the animation I've also programmed for the drone. Anytime I move it, its rotors rotate.
This is the version 1 of HoloLens or the version 2?
2.
Version 2. Yeah, it's
Yes.
much better.
Yeah, a lot better.
A lot better, yeah.
There's like a big difference. I was very disappointed with HoloLens 1 when I first tried it on,
Yeah.
which was 6 years ago. It wasn't what I thought it was, but 2 changed it.
Yeah.
And one of the best part about MRTK is it's very cross-platform. So the second video I'll go into shows MRTK being used on my mobile device, on my Android phone. So this is me experimenting with augmented reality cars, but with cool visual effects. All right. So this is me actually testing MRTK. Still Microsoft's same framework used for HoloLens, except on my Android phone. So this is me just experimenting with different type of car models and then kind of weaponizing it, kind of just making it a little bit more fun and interactive. Right. So that's with the car. I'll go in the next one with the robot. So the next one's actually my favorite. That one's actually using MRTK3 with the HoloLens robotic grip manipulation. So this is manipulating. So this is actually something I got from a Unity open source, and then I modified their robotic manipulation toolset with MRTK3. So it's actually on my GitHub. It's open source to anybody that wants to utilize it. All right, so actually let me move this a little. So this is using so we're all familiar with MRTK3, the latest mixed reality toolkit. So the previous couple were MRTK2. This is 3, which came out 2 years ago. This is back when it was new. There weren't so much documentation. So there's a whole documentation I wrote on it as well, which is on my GitHub, which Shahaf, I'll send to you after talk if you want to share that with the whole group.
Yes.
Yeah.
Yes. It
I would love to.
Yes. Thank you.
This is me trying to pick up that cube using some grip manipulations and physics and kinematics with the robot arm. All right, I'll skip a little bit because
kinematics has been made with Unity?
Unity.
Yeah. Okay.
This is all Unity right now. Yeah, I'm a Unity guy. Like I said, I'm still a newbie with Unreal, but that's something I explore in my free time. I know Unreal also has some cool raw support as well.
Yeah. Has. Unity is also great. I also made in my past using Unity an Android app.
Oh.
Yeah, for architectural visualization.
Oh, that's awesome. Okay, so I'll skip a little bit. That's just me interacting a little bit more. But that's pretty much with the whole MRTK3 open source robotic hand manipulation. So that's all based on user interface and gesture interactions. So then now the next one is more about visualizing a point cloud through the HoloLens device, but using it Azure Connect DK. How many are familiar with the latest Microsoft Azure Connect DK? Just raise of hands. All right, so Azure Connect DK is pretty much a built off of Xbox Connect, but it's not gaming use. It's used for real world application like robotics, body tracking, point clouds, and really so much more. Also there's surveillance you can use for Azure Connect DK as well. It's meant to be it's AI powered, so but I don't know if Microsoft still continue the Azure Connect DK. That's something I'll have to look into,
I've used
but
it. I've used the first one.
oh, real the Xbox Connect?
Yeah,
Oh yes, yes, that's I've used that
I've
too.
used it with a PC.
Oh
I've connected
wow.
it to a PC, yeah, and I've made like in a lobby of a company. I've made some screens that represent a 3D model that when
Oh.
people will pass by it, it will look at them.
Oh wow, that's actually really cool.
Yeah, it's nice.
Yeah, I know Microsoft discontinued. I know Unity because Microsoft discontinued support for Unity or something when they discontinued the Xbox Connect.
Yeah, but I've used it with some library that I found, but not with Unity. I've used it with other program.
Is it Python?
No Python. It's actually it uses Python, but let me remember. I'll tell you later.
Yeah, sure.
Later.
But anyways, I'll get to this. So this is a quick point. So I'm using an ISAR streaming SDK. So it's capturing all my real-time 3D reconstruction from the Azure Connect DK and streaming that to the HoloLens 2 in real time. So anything that my Azure Connect camera captures will all be directly streamed from the HoloLens 2 depth sensing camera. So this is me putting on the HoloLens 2, so I can see everything from the HoloLens. And actually, this is built off of the inspiration took place from Takashi Yoshinaga's point cloud visualization, but just a plain Azure Connect DK. For those in the XR space, Michael, you probably know the name Takashi, right? Yoshinaga?
I've heard of it.
He's a very big XR figure with this type of work. So
Okay.
the inspiration.
By the way, the program that I used, it's Touch Designer. If you know the Touch Designer, it's like a program that uses also Python in it for programming like screens and visualization of also with machine learning and everything.
Oh, wow.
Yeah.
Right. Next one is a VR simulation for postpartum hemorrhage. So I did this at a hackathon with a biomedical hackathon at Rutgers where we won second place prize. So this is like a brief simulation of what to do when you're treating if you're treating a woman experiencing a postpartum hemorrhage in a hospital setting after giving birth. This was like, yeah, this was just like a brief prototype testing. But we never took it though so far after that. So this is using the XR interaction toolkit. And then the next one I'm going to go into utilizes MetaQuest hand tracking using the Oculus Quest 2. So I'll skip a little bit. So if you see this, I'm able to grab. So this is just using my bare hands, no touch controllers, just plain old hand tracking. I can grab objects just like I can do in real life. Just with my own bare hands through the depth sensing camera inside the Quest 2 that's rendering my virtual hands in real time and then capturing that data and then computing all the interactions. Right, so shows that. I'll go to next slide. All right, so now the Internet of Things. So as previously mentioned, there's a variety of applications in Internet of Things. One area is of obviously your smartphones. The latest phones they use Wi-Fi. Phones always use Wi-Fi. What am I saying? Or your smartphones, they use Internet of Things, especially if you're working with like certain sensors, like the LiDAR sensors, for example, on iPhone. How many of us are iPhone users? Just raise your hands. All right, so how many of us have a LiDAR sensor on our iPhone?
Which sensor?
A LiDAR sensor?
I think I have it
LiDAR?
on my
If you have an
LiDAR.
XR phone, then iPhone XR or iPhone from 12 maybe 12 version. It's heavily there.
Okay, so I edit.
All right, yeah, there's
Uh,
probably IoT also you could use for that for certain areas like trying to think like Bluetooth connectivity or like for drones and robotics purposes. There's like IoT that your phone can also use for controlling a drone. Like it's an area known as mobile robots. So you would rely on IoT to control a drone from your phone.
okay,
Yeah, mobile
nice,
robotics is a very hot field right now.
nice to know.
And then of course smart homes. I mean, smart homes is, I think, the big future. That's another sci-fi world we're headed toward. They're using Internet of Things. Your house powered with like Wi-Fi, like for example, like smart light bulbs that you can just tell to turn on and off. Amazon Alexa. How many of us own a Google Home or Amazon Alexa? All right, so like I know one area that Alexa is really good in right now, training through data sets. And this is a project I saw somebody made at Big Red Hacks. It's a hackathon at Cornell University. Somebody did 8 years ago, where if someone was to come to your house and ring on your doorbell, Alexa would know exactly who the person is through like using Internet of Things, machine learning algorithms, and data training. It could be able to just recognize the exact name of the person who's at the doorstep. They'll say, "Hey, Bob is at your doorstep. Steve is at your doorstep." It was a really cool project. And then, of course, agricultural. So, as I mentioned, drones for deforestation or irrigation or crops, helping out farmers in certain tasks. That's also utilizing IoT, especially for drones need certain Bluetooth sensors, Wi-Fi sensors, especially if they're streaming certain information back to a computer server. And then, as previously mentioned, healthcare, so fitness tracking. Like, how many of us have an Apple smartwatch we use? Okay, so Apple smartwatch would use IoT for fitness tracking, such as such through certain sensors. It would be able to capture your heart rate, your body temperature, your oxygen level. All right, Michael.
But it's not the Apple Watch. It's an Amazfit. It's something else.
Oh no,
But
oh
it's
that's all you.
connected. It's connected to my Android, and it's a smartwatch, but it's not Apple Watch.
Right. Perfect. Yeah, so you would connect that smartwatch to your mobile device, and then anything from your smartwatch will stream to your actual phone that you can see all that data. And then,
Yeah,
of course, as I mentioned previous time, a heart rate sensor, like a physiological data sensor that you attach to your fingertip that calculates your heartbeats per minute. So actually, I'll be showing a couple of videos on that shortly. And then tools and platforms for people wanting into IoT, you could be though the IoT is both hardware and software, and hardware software interfacing and integration. So for that type of stuff, some of the tools you probably want to know are Arduinos, Raspberry Pis, Particle Photon. Those are the hardware components, and they'll be programmed in machine level language known as C or C++. And then some of the software like servers you could use are like cloud servers, such as Amazon Web Services IoT, Google Cloud IoT. There's also other, I'm sure, IoT cloud services out there that I probably wouldn't know about, since like IoT right now, there are just so many things, but it's it's a booming field. So I'll show a couple of examples now. So this one is me using, Michael, I know you're an Unreal fan, so this is me using Unreal Engine 5. This is the last
great,
year project I did,
great,
where I integrated real-time pulse physiological data sensor to monitor my heart rate in real time using
nice.
Arduino microcontroller that's then integrated into Unreal Engine that can stream that data. So I'm going to show that little. So this is me. This is the fingertip connected to my hand. Okay, so now as you see, if you see the UI that's in white, it's showing 0, but that number is going to change pretty soon. So now if I press spacebar, it says uh, it's basically showing the serial communication is detected. So now do you see the numbers changing from 0 to 60? So move a little bit more. So this is actually me moving my
It's a bit
fingertip a little
hard to
more.
see the numbers because it's a small screen.
You want me to go to
Yes,
YouTube? Should I just go to YouTube real quick and then come back to the slides? Shahab,
yes, it's possible.
You
You can or
you
send
can
us
also
the
use
URL.
you can
sorry,
also
repeat that.
use the controller and your scroller wheel to closer.
Sorry, repeat that.
Zoom in
I
your
said you can
screen.
we can also zoom the screen with
Oh,
controller
like
and the
this?
scroller wheel.
Okay,
Yeah.
okay, cool.
Exactly.
Oh, oops. Okay, let me actually zoom in. Okay, just let me know if that's better.
Yes, it's perfect.
Okay, let me move this a little aside. Okay, how do I press play now? Wait 1 sec, I gotta press.
You can jump to YouTube if you want. It can be better.
Okay, I might have to reconnect here. 1 sec. Oh, now okay, let me actually come back to the screen. Okay, oops. Okay, now I can, okay, let's go to YouTube.
Can we stop with the self-care
Can
weeks?
everyone
What
see
if we
the
did
YouTube?
adult weeks instead? Think about it.
Yes.
Instead of laying in bed and rotting away, we literally
Yeah,
just
no
dedicate.
problem.
Now it's perfect.
Much better.
Awesome, okay, I'll skip a little. Okay, now better?
Yes.
Perfect,
It's
all
good.
right. So now you see it shows my port is initialized. If I press the spacebar, it's sending data. So now if I move my fingertip, it's gonna change the numbers a little bit. All right, so you see it change from 0 to 60, 48 to 50, back to 0. Now 150 if I move my fingertip. I'm sure you know a little bit goes, the heartbeat goes a little out of rate because the processing power with it's such a like small sensor that the processing power is so fast that the numbers may go a little out of range, but the concept of proof of prototype is it's picking up numbers, even if it's a little inaccurate. But yeah, the proof is it's attached to my fingertip and it's working.
Amazing.
All right, so okay, so we'll go back here. All right. Same thing for here. If you can't see clearly, just let me know. So the next video, I'm using a particle. This is in Unity now, using a particle photon microcontroller to calculate my vitals, heart rate, beats per minute, real time. Still using physiological data sensor, but wired to a particle photon microcontroller instead of an Arduino. All right. Hang on. Oh, is the text clear in this one, or you want to, for this one, for everybody, a little bit more clear versus the last one?
We can see it. We can see
Yes.
the
Yes.
numbers.
Readable.
Okay. Oh, oops. What? Oh, sorry. Oh, okay. All right. All right, so as you know, it still goes out of range, the numbers, but it's still capturing my heart rate. And this is me streaming it through the HoloLens 2 device. So this is actually streamed from Unity, then exported to HoloLens, and then the pulse physiological data sensor attached to my fingertip is then a URL using IoT concept is through a URL is also then through a cloud server, which then gives a URL data, which then streams the data in real time to my HoloLens. All right, so now embedded systems. So embedded system, as we all know, it's the core concept of IoT devices and real-time controlled systems. So you can say embedded system is like the body, the IoT is like the brains behind the embedded system. It's the main power source. So as previously mentioned before, embedded systems, that's a broad term that's used in a variety of things, such as wearable health devices like smartwatches. They use IoT and embedded systems. Fitness trackers, robotics technology such as self-driving cars. So cars use self-driving cars while they use embedded system like a computer system with IoT, such as let's say if a car gets in an accident, it can then send it can there's like there's a Bluetooth or there's something built into to the car within like certain sensors that if you get into an accident, it would then like send a 911 call, I think from your phone, if linked to your phone, that there was a serious accident that occurred. So
I
that's
think you
another
have a
area that's using.
modem in the car.
Oh, sorry, you were saying?
I think you have a modem, like a cellular modem in the car.
Yeah, that's what I'm trying to. Yeah, that's what I'm saying. Like there's some cellular modem that's being used. Yeah, and then other areas, of course, automation such as industrial automation, robotics being used for factory purposes, such as collecting and packaging items, real-time control in automated systems. So, for example, such as one example is obviously self-driving cars. Another real-time control could be, I'm seeing another good example. Anyone have a good example that they can think of? Actually, let's see.
Agriculture.
That's a big one. Yes. Yeah, so agriculture, like controlling a drone. The medical devices, obviously, we've touched upon that. But Another area that this is my favorite area of embedded systems is game controllers. So such as like programming an Xbox or PlayStation controller or a joystick controller. So there's like joystick controllers that come built with Arduinos that you can wire up to Arduino to control a character within a game. And for this, obviously, embedded system is more hardware, so it's like it relies on software, but it's low-level software, machine level, so it would be C and C++, obviously. But the tools you'll be looking into for this type of stuff would be Arduinos, ESP32, STM32, and FreeRTOS. All right, and then let me show some demos of some embedded systems that I'm using in video games, applying to video games. So the first one I did a hackathon project 4 years ago called NatHacks. It's a brain-computer interface neurotech hackathon. So just for fun, how many of us are familiar with the term brain-computer interface and neurotech? Raise of hands. So neurotechnology, it's built off of neuroscience, but it's neuroscience in engineering applications. So neurotech, it's brain technology, but it's from neuroscience from a very technical point of view, from an engineer's perspective. So brain-computer interface, I'm sure we're familiar with EEGs, how we wire up like EEGs to our head. They can do a lot of cool things like mapping, but there's a lot of research happening in EEGs beyond just mapping, like controlling things with your mind, like playing a game. So anyways, I created this game called Neuro Tetris to understand a person's cognitive thinking. So every time a brick lands on the ground, an LED lights up. So the LED is using Arduino, then the Arduino is integrated to Unity using this RDD framework, and then translate into real-time game. Right, so I'll skip a little bit. Oops. As you see, as a brick lands on the ground, a different mechanism happen to LED, so a different LEDs light up.
Michael, it remind me your project at the end of the course.
Oh.
Yeah.
Michael combined between Arduino and JavaScript and created a 3D snake game
Oh.
using
Yeah.
a photoresistor as a control
Yeah, I've
arrows.
used four resistors for the arrows, and when you're blocking a photoresistor, the snake will go to this direction.
Oh, wow. That's really cool. Oh, let me go back. My arrow keeps disappearing. Okay. So the next project first of all, Michael, you're gonna have to show me that cool project you made. I'm gonna have to see it. So the next project I'm gonna go into is the one area I'm a fan of, so so this is back when I was doing research in biomechanics with the New Jersey Institute of Technology. This project covers me utilizing a robotic exoskeleton device attached to my arm that I'm wearing, and then controlling this bar in a game. Or basically, it's like a old classic little brick breaker game, but instead of brick breaker in the old-fashioned way, we're doing it with the exoskeleton. And the exoskeleton is wired to Arduino microcontroller, which then sending serial data Unity, translating my kinematic input to real-time gameplay inputs. So this is me starting the game. And I also added some voice commands, so I can just tell it to launch instead of pressing the button. And this is the goal, is using this for physical therapy for cerebral palsy patients.
You think I've got it all? Everyone thinks. You think I've got it all? Everyone thinks I've got it made well. How come my only friends are the ones I pay? No one knows.
Oh, let me see my arrow. Oh, okay. Okay, so the next one now I'm going to show is going to be me controlling a cube in Unity also, wired up to an Arduino microcontroller, but with a joystick controller. So this one's a little bit more simpler, but it's using similar concept, but with Arduino joysticks. So can everyone see me controlling the cube with the joystick?
Yes, we do.
right? So me controlling this, all right. So it's pretty straightforward. It's just a simple prototype, right? Then I'm going to go to next. All right, so now opportunities for students in emerging technologies. So this is really important. So I talked a lot about stuff I've done, a concept of emerging technology, and then really what each of them are. But I think Shahaf, the goal, I think this, from what you mentioned, this group shares is involving the next generation of students in this stuff, correct? And how they can get involved.
I think that most of our community are already with old bachelor or master degree, but some people, some members try to change their career or open their mind to new opportunities in other parallel sectors and try new things, maybe. So,
Awesome. Yeah, so really, if for those who are changing careers or new or just starting college or whatever, there's so many ways to get involved in emerging technology. So one area is doing hands-on projects. So for example, take a course on Coursera, Udemy, or you watch a YouTube tutorial and just learn one specific technology and then just get hands-on and learn about it, learn what the purpose technology is, what problems you're trying to solve, and do some fun hands-on projects. So there's many ways, creative ways to get involved. You can take a Coursera course, you can watch a YouTube tutorial, you can do self-learning in your free time. And then of course, other engaging ways is participating in STEM competitions like hackathons or maker events to gain real-world experience. So how many of us done hackathons before? Raise of hands. I'm a hackathon veteran myself.
I was in a hackathon back in like a long time ago.
I see.
Isn't it
Yeah,
in Unity, but it was a really one in my early days with Unity.
got it. So hackathons are great ways to get involved, especially when you're a student, whether undergrad, master's, or career changer, because hackathons really give you that real world experience. Plus, they give you open networking opportunities and doors to internships and jobs and just putting yourself out there. And then there's other types of opportunities also available outside of hackathons. So of course, there's student hackathons like MLH events. How many are familiar with Major League Hacking? It's a very popular organization. Okay, Major League Hacking is a student-oriented hackathon organization that powers university hackathons. They're the people that help fund university hackathons and provide hardware equipment. And then there's Microsoft Imagine Cup. I'm sure we're all familiar with that. I'm sure some of us did that as students. And then there's also more specific professional hackathons like game jams or AR/VR hackathons or MIT Hacking Medicine and more. So hackathons are just specifically they're tech events that are meant to help you innovate and come up with your own ideas, but also learn and really just have fun. And then there's also other ways to get involved, such as research and internships. You can explore internships and research opportunities in fields like AR, IoT, AI, robotics, or biomedical technologies. Like, for example, if there's national labs in your areas, you can apply to those places. Of course, do have something to show. Like, don't ever network. I always say, don't ever network with anyone empty-handed. Always have something to show that you've done in your free time and some experiences, even if it's not full work experiences, but something to show that you've been consistently learning and keeping up with the game. There's always university research groups you can get involved with, like voluntarily doing research with a professor, telling them, hey, I'm really interested in doing type of work. This is like what I really want to do. Is there any way I can contribute? Or look for startups. So early stage startups, like including my own startup, Julia Technologies, we're always looking for volunteers to help part-time, to help us grow. And as you help a startup grow, you're also gaining experience and you're seeing also how it feels how you're also seeing the exposure of what it feels like to help a growing company out. Like, because when you're part of a early stage startup company, you're kind of doing bits of everything, but you're also experiencing what it's like in growing as an individual and growing a company. And then, of course, there's open source contributions. Like, there's so many frameworks on GitHub you can contribute to. There's open source projects, there are development communities. And overall, build a personal website, show a portfolio. So whether you go to a hackathon or you do side projects or hobby projects or you got work experiences from a research lab, industry, startup, or whatever, try to record these projects in some ways. Have a track to show your projects on a portfolio. So your portfolio can be your personal website. Have a personal website where you talk about each and every project you've done. in specific detail and where you've specifically contributed and what you gained from it. It's a good way to market yourself. And then, of course, there's online learning resources. So like Coursera, edX, or Udemy. If there's Udemy also, they have a lot of hands-on projects that they make you do through end of their courses that you can showcase on your portfolio. So having a portfolio is always good because it demonstrates your technical skills and how you keep up with the game. All right. And thank you. And I'm happy to take any questions.